Hi, my name is Jeremy Anglin, and in this video I wanted to give you an overview of how, in a recent paper of ours, we have shared our data, scripts, materials, and preprints um, to sort of follow what we see as kind of, well, an attempt at best practice at open science. And so in this video I wanted to give you an overview of how we've gone about doing that, and also give you an overview of the R code and how that's all organized to represent a fully reproducible script that takes raw data, cleans it, scores it, performs some analyses that are subsequently incorporated into the publication. So yeah, I think this seems to be, where science is going in psychology. A lot of journals are pushing for sharing of data where possible, greater use of scripts, and I think it's fantastic. And one of the things that I think causes a challenge to researchers and to myself included is, how do you do this? How do you actually? What are the concrete steps you need to go through to make your science more open? And in putting this repository together on the Open Science Framework, I had to work through quite a few just small challenges. So I wanted to share with you how we've gone about overcoming those challenges. Okay, so this paper um, is it's a paper with quite a large sample size. We had over 1,000 people complete a large measure of personality and a measure of one of the dominant measures of values, which is Schwartz's personal values measure. So I'm not going to focus too much on the substantive aspect of the paper, but if anyone's interested, then this data set and these scripts are particularly interesting. I wanted to focus more on what we did to make this research open science. And hopefully it's of relevance to people doing research in personality, psychology more general, and the R code might be interesting to anyone. Okay, so this is the Open Science Framework website. So you can see up here the project has a stable long-term URL. It's quite short. It's a bit like YouTube, it's that quite nice and short, so it's easy to plonk into a paper and not take up too much space. The Open Science Framework is a free website which basically adopts all the kind of nice things you'd want from an archived scientific based website. So I won't go into all the features, but I'll just highlight what we've got. We've got this page for the project. You can see the contributors, that you can have an abstract. There's a wiki page with more details. And the core of it really is these files that are stored on the OSF. So these are archived with a long-term storage plan, and even plans for, if the site was to go obsolete, there's backup for the long term. So what I have here is I have the analysis, which is a zip file with all the R code and data and so on. I've got the raw data, or the clean data in CSV and R format, which could be looked at directly. And we have a copy of the preprint. So you can certainly download any of this data if you wanted to make use of it again to do some further analyses on a large hexacose sample or values. And so just by clicking on, say, the CSV file, you can either click to download. And nice thing of OSF, you can even just view it in the OSF. It takes a little while to load because it's quite a lot of data here, but if you give it some time, you can actually look at the data, and you can see what's available. So in this case, we've got item level data on all the values items. So there's quite a few of them, maybe 60 odd or 50 something. And then you've got item level data on the Hexaco 200, so lots of that. And then finally, much further on, you've got the scale scores and a few other variables that were generated to sort of check data cleaning and so on. So outlier scores, whether they were problematic and so on. Anyway, that's there. The documentation for this could probably be a little bit better, but the R script certainly makes it clear how everything's scored, and I think it's a fairly self-explanatory data. Metadata is largely available in the analysis script. Okay. Another thing that OSF supports is preprints. Traditionally, there's been the archive is a very popular preprint server for, I don't quite know the disciplines, but things like I think mathematics, perhaps physics, and those sorts of disciplines. Open Science Framework has its own preprint server, which its name, I believe, well, I think the Open Science Framework sits underneath a number of new discipline-specific preprint servers. So for example, there's one called the Sci Archive, which is for psychology-related work, which is what my field is. Or I think you can just have a preprint link through the OSF. So essentially I've uploaded a PDF preprint of the work, and you know, this files is I've done a little bit of formatting to it just to make it a bit prettier than the typical double-spaced tables at the end format. So if you want to have a read of the actual paper, either because you're interested in it or because you want to know what the finished product of the R script I'm going to show you in the end looks like, you can view it here or you can download it. And yeah, if you download it, well, it'll open up. It's also linked. I had to do a couple of things just to set it up as a preprint, and that's you know, that means that it sort of has its own preprint page, which is kind of nice. That can be shared. And yeah, so you can see the preprint. I'll just show you quickly. So there's part of the analyses involved, you know, a whole range of tables. Correlations are all over the place. It was a moderately complex analysis, I suppose. You can also see that I've linked to the OSF in the repository in the paper. So, for example, yeah, you've got these tables which were, I guess, in some sense generated by R. Correlations between personality and values, but also some clever things, I think, like the mean absolute correlation by row to see which personality facets correlate more with particular values. There's also, if we go further down, there's some regression models where we look at different predictors of values. So, you know, and by values, I'm talking about things like, you know, whether a person likes stimulation, hedonism, a desire to achieve, a desire for power, security. This is the substantive aspect of the paper. But the kind of thing we're aiming to do was to see how different sets of personality variables predicted different values. And we're seeing here the adjusted multiple R. And so, you know, there were substantive questions about, you know, to what extent does openness lead to additional prediction? To what extent does this new honesty, humility, well, newish honesty, humility factor add prediction? And so this is quite a nice table, and I won't go into it, but quite a lot of, each one of these cells is informed by a regression model with a certain set of predictors. And there's also some summary code to get the average prediction, you know, across the 10 values that form the Schwartz personal value scale, which provides a nice synopsis of, well, how well, for example, the 5 hexacofactors with honesty, humility excluded predicts values. How much does adding honesty add? How much does having the narrow facets of personality improve prediction? And some comparisons and so on. So what we're seeing here is I think, yeah, a moderately complex table. There's a lot of analyses informing it, and so it's quite nice to have an R script, which I'll show you shortly, to inform that. Okay, so let's have a look at the R script. So this is probably the section of this video that's probably more important for people who are just interested in the R code and how do you organize it. So, I mean, you can use services like GitHub or so on that would allow people to browse the code more easily. And I believe there's even ways of synchronizing releases of GitHub using things like Zenodo to generate a truly archived copy. But for here, I've just literally uploaded a zip file. As a side note, this zip file did involve a bit of cleaning to get just the files I wanted to share, and there's a few kind of, there's things you don't necessarily want to upload to the repository, like rough scripts that aren't really polished, or some brief exploratory analyses that never went anywhere towards the paper. So this is a kind of a clean version of the repository. It also does a few things like remove some variables that might relate to the identifiability of participants and so on. Alright, so let's download this file. So I'll download it. It's a zip file. So it's downloaded to my computer. And there it is. So I've plonked that zip file in, and if we have a look inside, it's organized in terms of my project template workflow that I prefer. There's lots of discussion about project template on the internet. So you can learn about it here. I also have some videos which you can check out on project template. There it all is. And you can also read more about project template on my website, where if you do a search for project template, I'm sure there'll be some information about my workflow. All right. So in essence, we have an RStudio project file, and then we have a number of other folders and files that relate to the project. So you have the data in the data folder, configuration information, supplementary functions, data processing in this R script, and output is generated here. So this is actually a copy of the output that's generated. So let's open this thing. Hopefully you've got RStudio installed and R installed as a starting point. That's assumed, I guess. In the README file, I have installation notes. So first I'll say quickly about how you get this code running if you're wanting to run it on your own computer. So I assume you've got R installed, I assume you've got RStudio installed. There's a bunch of packages that you will need. This should be project template. I might update it at some point. So to get started, you definitely need a project template. So if you don't already have that, you'd run project template and click that, and that would install it. Or you could use the project. There it is. That's perhaps more intuitive if you're using RStudio. So you install that. I've already got it installed. And that will allow you to run project template stuff. There's also a bunch of other R packages that are used. So in this global.dcf file is this row called libraries, and we see that we've got the psych package, lattice, HMISC, personality facets. To be honest, I'm not sure if I used all these things. They kind of grow as the project evolves. But yeah, you would need all these installed on your system. And the only problematic one is personality facets. This is a package that I've created and haven't yet released to CRAN. So if you'll need that installed, and to get that, you use DevTools to download from GitHub. And once again, if you don't have DevTools, install.packages, DevTools, and then you should be able to run that code. And well, it's telling me that I already have it installed, but that'll install it. Otherwise, all these extra packages, I think in the latest version of Project Template, will auto-install if they aren't already installed on your machine from CRAN. Yeah, as for other dependencies, I'm not sure. I think that's probably all you need. Okay. So the core analysis file, let's just have a quick look at that. This is explore.rmd. It's an R Markdown file. So we have a bit of, let's go over that quickly. We've got some configuration on the R Markdown file. We have code chunks with this triple backtick brace. And essentially how I organize my R Markdown file is that the first chunk kind of gets you started. The idea is that once that's run, you should have all your data, clean data, everything should be ready to go. And that's what project template does. So this one line loads the project template library and then loads the project. That's a project templates function that ultimately does a whole pile of things. And then we have the substantive analyses in these chunks, chunk after chunk with different substantive analyses. So if you wanted to see whether you've got it all up and running, the hardcore way to do it is to press knit to output. And if everything's set up right, you've got all your packages, then you should be able to click knit and it will generate this PDF. So it runs all the code, generates the output, and there's quite a few functions in here that generate little CSVs for the tables that I use in the paper. Anyway, there it is. Okay, probably one other dependency you may need is to generate a PDF, you may need to have a LaTeX installation. You could probably remove this and knit to HTML if you don't have that, and you can probably still see it that way. Or you can just run one chunk at a time and see what it looks like. Okay, so I wanted to give you a bit more of an overview of how this project template works. So when you run load.project, a number of things happen. So I'll just quickly, I'll run that and you can sort of see what happens. You can see that first it checks configuration and basically loads packages and checks any kind of settings like whether strings should be factors or strings and so on. Then I believe it would source any scripts in the lib folder. So I have a bunch of scripts. I'm not even sure if I used all these things, but there's a bunch of scripts that just got built up over the course of the project. So they get sourced. Then it automatically loads the data in the data folder. So I have some raw case data and also metadata. I've placed it in this R data object just to make it more reproducible. For my own work, I tend to have data stored in Excel or SPSS even, because they're often nice formats for editing or exploring it outside of R. But for reproducibility, that often creates a few dependencies, so I've kind of, as part of my export script, I've made sure that the source data is in R data format. Okay, I won't go into the contents of that, but that's what happens next. Then we run the munge script, so all this code in here gets run, which is designed to, I guess, transform the raw data in some way to make it suitable for what will ultimately be the analyses. And the idea is so you're ready to analyze. Okay, so I'll clear this workspace and I wanted to go through the munge file a little bit. I wanted to show you what I do for data processing. Now, one line I always have at the top here is this comment out version of project template and then load project but munging equals false. So what that does is it runs the load project function in project template, but it does not run the munge script. It only runs the, loads the packages, sources anything in lib, and loads the data. But it won't run this script, and that's really nice when you're actually editing and debugging your munge file. You want to kind of, so I'll run that, and what it does is, it's gotten me to this point in the code, and now if I was actually writing this script, that would be quite nice because I could then edit it in real time and see the effect. And if I've got problems, I would see that in the normal, natural, interactive debugging environment. Okay, so there's a bunch of things this script does, and I wanted to just draw your attention to a few things. So in psychological research, we often have sets of variables which we reuse multiple times. We often want to clean our data. We often want to score and create new variables, particularly like surveys and questionnaires where there's a scale score which we want to use in subsequent analysis. So we often need to score a test. Okay, so I'm going to go over those few things. So first, variable lists. I love variable lists. They're awesome. Awesome. They make things so much easier, so much more consistent, so much more reliable. The idea is when you run analyses, you don't type the variable names yourself, you source a variable list. So for example, I always call it V. It's consistent and it's short, and it means that I can quickly get autocomplete. So what we see here is I've got this V list and V dollar. There's all these sets of items, and they're often drawn from the metadata. So in the metadata for Hexaco, for example, I have all the scoring information for that, and I also have a column that corresponds to the variable name, the ID. And so if I wanted to get all the Hexaco items, say I wanted to do a factor analysis on them, I could quickly source that particular variable name, and there they all are. Here's all the values items. They can be sourced easily enough. If I wanted to do a factor analysis of the whole lot, I'll often combine these two, different variable sets into a larger superset, which can be called in a particular analysis. And likewise here we see if I wanted to include, say, all the Hexaco facets or the factors, they're all there. All the names that I'll need for my subsequent analyses are there. And often as I'm going through analyses, I recognize a set that I will need to use on more than once. I'll go back in here and specify them as a set. It's really, really good. It means that the order of the variables in your tables are consistent across tables. It means that it's easier to consistently combine statistics into some sort of composite table because you know that the order of things are the same and so on. So yeah, absolutely love variable sets. They're really good. And I think I have a post about this on Stack Overflow if you're interested in it. So many years ago I asked about selecting variables, and there's a post here where I talk a lot about variable sets and what I'm doing. So if you're curious, just Google something like that and you can have a read. Okay. Next thing I want to talk about was data cleaning. So almost always in research you have some raw data and you have some cleaned data. The raw data may have problems. You may have missing data that needs to be imputed. You may have cases that are just no good and you want to delete. In our research in psychology, often people don't complete a questionnaire completely. They only do half the items, or some participants respond randomly. Some don't satisfy a manipulation check. So I always, well, just about always, I kind of have this convention of attaching an R and a C for my raw and my clean version of a particular data set. So I load the raw data, which I'm calling R cases, the raw cases. I'll do some analyses, and then I'll work out which ones are valid, which should be retained for the substantive cleaned analyses. This is nice because the decisions are clear, and also sometimes you want to run some analyses on the raw data. So you might want to say, oh, well, has some result changed versus raw versus clean, or what's the sample size of the raw data set and how much has it been reduced in the cleaned? This is often important information for the methods section. And so, there's a bunch of stuff here, getting missing data count, Mahalanobis distance for outlier detection, and so on. So essentially, what I end up with is R case is valid. I can't even remember. Let's see, was there any? I think this was, the data that I received was pretty good, but yeah, there were 4 cases that didn't pass some check that I specified up here. I think I had some issue of if someone gave the same response to every single item, then that was problematic. So then I assign the valid cases to clean cases. You might also notice that I'm using the variable sets a lot up here. So that's much nicer than having to write out the close to 300 or 260, 70, whatever items that make up that. I can do a missing data count on all those items without having to have this massive long list and worry that have I specified it correctly and consistently. So yeah, variable sets are awesome. Okay, so we now have our clean cases. That's good. C cases. Second thing I wanted to show you was scoring psychological tests, or any scale, multi-item scale that gets added up to a total or a mean score. I do this a lot, and you can imagine with a personality test with 25 facets, 6 factors, that's 30 variables that need to be scored. That's 30 reliabilities I need as well. And likewise with the values scale, that's another 10 variables I need. So that's, yeah, and likewise another 10 reliabilities. So I've tried to package this into something as neat and tidy as possible. So I've created my own little function that sits on top of a function inside the psych package. So score test, this is what it looks like, and presumably somewhere in here is the score test function. So this is designed to be as neat and tidy in the Munge script as possible. Essentially, I have metadata, which explains how to score the test. So if we look at the first few row of meta.hexaco, we see the ID of the variable. So that's the variable, what it looks like in the data file. So I guess C cases hexaco 1, that's the actual variable. You have whether it needs to be reversed or not. So some items are negatively worded. So I'm frightened of people might be a negative extroversion item, for example. And then you have the factor. So that's the variable name that the scale score will get. And anything with a common variable name here will be scored into that test. We have the data. This is the column that stores the variable that's going to be created. You have the column name in the meta file that represents whether it's reversed, and so on. So I use this list just because, yeah, we also get reliability out of this function as well. So if we look at this thing, we can see that we've got a bunch of things returned, including alpha, which will be important for the method section. And the second line assigns the actual scores. So these are the mean scores on a 1 to 5 scale for these personality facets into C cases, etc. And likewise, we do the same for the other scale scores. Yeah, there's a bunch of other stuff going on here to do with ipsitization and so on, which I won't go on about. Okay. So that was the Munge script. We've got variable sets, we've cleaned our data, and we've generated important scale scores that are going to be used in subsequent analysis. Now I wanted to talk briefly about running some analyses and how that looks like. So essentially, I've got all the analyses arranged into these different code chunks. So I'll focus on perhaps, well, let's have a look at something like these initial exploratory analyses. And you can look through this script and see the kinds of things that are done, but what we have here is some initial factor analyses. Later on, we've got correlations and regression models, just like is in the table. So some of this was exploratory. A few of these things probably didn't go in the table into the final report, but most of it did. So, for example, here's a factor analysis of the SPV items. What might be interesting? maybe we'll go down to here. So this is in the supplementary data, I believe. This is a factor analysis of the 25, is that right? 25 facets of Hexaco using 6-factor solution. And so that runs a factor analysis, and we can see the loadings cut off at 0.35 and see how cleanly these facets load. So there's a few cross loadings, but mostly the facets that should be loading together are loading together. And likewise in the report, I believe I mentioned the variance explained by each unrotated factor, so you can see some of that stuff there. You can see how we get the alpha statistics out, so it's stored in that big long list. I've got all my Hexaco facets, factors, values. So this is extracting out and making use of that score function I used earlier. So now I have the alphas extracted, which can be combined into a table of mean standard deviations for different aspects of the data. Let's see. All right, so I don't think I've fully run this Munge script the first time, so let's just make sure that that's good. And let's see if that will now. Okay, that's better. I don't think I created the variable sets yet. And so, yeah, here we have a table, RVDesk, which was the descriptive statistics with alpha for the basic values. So we have mean, standard deviations, and alphas. This is a template that gets used a lot. What I usually do is then, so you can see I've created the data. It's not rounded. It's nice to round before exporting, because you don't necessarily want to rely on either you rounding properly, rounding up or down, or certainly not relying on Excel, because it will round visually rather than, that won't round numbers up unless you do some additional steps. So I apply a round function to get to the decimal places I want, and then write it to an output file. And so what we have now is in the output folder a bunch of files, and I mean these all get generated by this longer script, but you can certainly let's just I just wanted to briefly show you what I might do with something like this to get it into a shape suitable for a journal article. And I've been talking recently about how to automate more of this, but ultimately, as much as I love fully reproducible research, where code generates tables and numbers that get automatically integrated with a manuscript, there are pros and cons, and as much as I'd love to be fully reproducible in that regard, for now I'm finding it more efficient to do as much as possible as this automated, but then still have a manual process of incorporating it into the manuscript. Table formatting is still a challenge. Collaboration is still a challenge. So anyway, so what we get we can open this and say Excel. I usually have a separate Excel file which is used to do the formatting of these things. So you can change the labels slightly, change the number formatting, how you think the decimals should be, put in line breaks, you'd probably fix up, I think I've got, fix up the capitalization or whatever it might be, and so on and so on. Perhaps change the alignment, change the font. adjust the column widths, and then that should be basically something that could go in a table. Then you could have table 1, blah 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 blah, italics, and then put in your note, etc. So yeah, that's how it works. That's the full workflow from exporting a table to getting it into something that's of suitable quality to put into a journal submission. Okay, so yeah, there's lots of other stuff in here which you could look at. So for example, you can get correlation matrices, easy enough. So this is hexaco factor correlations, likewise exported out to the output folder. It'd be an interesting question if you are on Windows whether this raises an error, because I'm using \. I've also got some little summary statistics. So this is the mean absolute correlation between hexaco factors, and that is a number that is, I think, is incorporated somewhere into the text of the manuscript. So in addition to exporting tables, there's little numbers like that that are used in the text to summarize features of the data. Just to show you something more complicated, here is quite a complicated function that does that. If you remember a while back, the regression table. Where is it? So this table is relatively complicated. It's got a huge number of regressions predicting values from a range of different personality sets. And this was a big long set of commands at one point, but then I think the reviewers and I was also interested in this question. There were two ways, or at least two ways, of scoring the values, ipsitized and non-ipsitized. And so the reviewers mentioned, well, what happens when you don't ipsitize? And so that meant, well, we sort of wanted to see what this table looked like without ipsitized. And we didn't want to just copy and paste the whole code. It'd be much nicer to have a function. So what we see here is a very specific kind of function that creates that, or pretty much all of that table, but it's set up as a function so that I can change the DVs so that I can use either the ipsitized or the non-ipsitized functions. And I think even as I was going along, I realized I wanted to add something else to it, which was to show the largest facet or factor prediction. So that was a second function. So this is how this thing organically grew. And so this function supplies the values one at a time to this table and the different predictor sets, and produces that table. And you can see down here where we ran it with the unadjusted values here. So it's exactly the same table, but in the appendix we provide the same table, but using raw values. And we're able to include a little bit of code that looked at the correlation between raw and ipsitized values, and we can show that on average they correlate 0.77, and even how the cross correlations of personality and values are similar or different based on the choice of approach. And so it's saying that the cross correlations vary. They're pretty similar whatever approach you use, but they're a little bit different. So that's probably enough. I mean, if you're interested in doing factor facet research, and I think this project is a really nice template. And if you're interested in scoring psychological tests, I think this is a really nice template. Yeah, I'll briefly comment on one last thing. We do have a make file, so it is possible to use make if you have that installed. You're running Unix or OS X. From the looks of things, it's quite specific. You'd probably want to make this a bit more general, and I have done that on other occasions. But it was quite nice as a quick way of checking that my export was able to run this whole project. So anyway, that's my overview of this project. I hope it gives you a few ideas for how to share your data and code. Yeah, hopefully proves useful to you. So yeah, thanks, and yeah, ciao.